This is the second part of the 3.5 notes. Today I'm going to focus on the special cases. So, we talked about the main idea of what the focus is when you have variables on both sides. In these cases, we had variables on both sides. We had to pick the smaller variable to move. We went over these. You had a chance to try it on your own. In this case, we did some simplifying first. In this one, we cleared the decimals and then we solved it. Here, we did distributive property. And again, here you had some practice of your own. So this is example 3, our special solutions. Now remember in chapter 2, it was possible for us to get all real numbers or no solutions. So you're going to see that happen here as well. Okay. So here we go. We're going to start with the first one. So first thing, if you notice, the x's are exactly the same. So it doesn't matter which one I move because I get 0 in both cases. So I'm left with the statement 5 greater than or equal to 3. Now, here's where you have to really think, and this is where it gets confusing. The question is this a true statement? Now this inequality says greater than or equal to. Now, when you think about it, the or means it has to be this or this. It cannot be both of them. So, as long as one of these conditions is true, this is a true statement. So look at it two ways. This says 5 greater than 3, 5 equal to 3. Well, we know 5 is not equal to 3, but is 5 greater than 3? Yes, it is. So the answer here is all real solutions because our variable's eliminated. Now, when you have this special case, you don't really have to graph it. Here's why. This says every single number on the number line is an answer. So if I just put a few numbers here, my graph literally has no endpoint. The whole thing is just done. Okay? The whole thing is the answer. Alright? So now let's try this one right here. Alright, so in this case I have to do distributive property here. So I get 2x plus 6 less than 5 plus 2x. Notice my 2x's are identical on both sides. That means they eliminate each other. And I'm left with a statement, 6 less than 5. So now, is 6 less than 5? No, it's not. So the answer here is no solutions. And again, just like in the first one, you don't graph it, because here's why. No solutions looks like this. Basically, it means nothing. There's no shading on your number line at all. So you don't have to do that, unless you want to. Okay, so that's what happens. So when your variables eliminate, check and see what the statement is left over. So try these two on your own. Try both of them. You have 3 minutes. Go ahead and pause the video. Okay, now that you've had a chance to do it, here we go. I'm going to distribute first here. Now notice my 4y's are identical, so they eliminate. So I'm left with negative 4 greater than or equal to 2. Now remember, this is a 2 condition. It's either greater than or it's equal to. So is negative 4 greater than 2? No. Is negative 4 equal to 2? No. This is a false statement, so your answer is no solution. Let's try the one over here. Nothing to simplify first, so I'm just going to go ahead and move my x's. So I'm left with negative 2 less than 1. So again, is negative 2 less than 1? Yes. So my answer is all real solutions. Okay? So hopefully you get the main idea today. It's not that difficult. Just know that when your variables eliminate, you do have a special case. And with the special cases, you don't need to graph because in this example, all real numbers, your graph is the entire number line. Everything works. Over here with no solutions, what that means is nothing is highlighted. So you just have a number line with no shading. Okay? Alright, so there it is. And that's it. We're done.